This is Melanie Fine of Chem in 10. Today we're going to talk about percent composition. Percent composition is the percent by mass of each different element present in a compound. These are the steps to determine percent composition. You first calculate the mass of each element present in the formula of the compound, and then you calculate the molecular weight of the entire compound. You divide the total mass of each element by the molecular mass and multiply by 100. Let's look at a sample problem. Determine the percent composition of silver and chloride in silver chloride. So the first thing we need to do is figure out the mass of each element in the compound. So we're going to look at molar masses. In the periodic table, we see that the molar mass of silver is 107.8682, and the molar mass of chlorine is 35.453. Rounded to 2 decimal places, the mass of silver is 107.87, and the mass of chlorine is 35.45. Next, we determine the molecular weight of the compound, so we just add these together, and we get 143.32 grams per mole. Finally, we divide the total mass of each element by the molecular mass of the compound altogether and multiply by 100. So the percent by mass of silver is equal to the molar mass of silver, 107.87, divided by the molecular mass of the compound, 143.32 times 100, and that equals 75.27% silver by mass. And the percent by mass of chlorine is equal to the molar mass of chlorine, 35.45 grams per mole, divided by the molar mass of the compound, 143.32. We multiply that by 100, and we get 24.73% by mass chlorine. If you notice, if you add these two numbers together, you'd get 100%, because the molecule is made of silver and chlorine. Sample problem number 2. Determine the percent composition of each element in ammonium nitrate. So we need the mass of each element in this compound, so we'll go to the periodic table again. Notice that we have 2 nitrogens. We have a nitrogen in the ammonium ion and a nitrogen in the nitrate ion. So each nitrogen has a mass of 14.01 grams per mole, and each hydrogen is 1.01 grams per mole. So 2 nitrogens is 2 times 14.01, which is 28.02 grams per mole. And we have 4 hydrogens. And if each hydrogen has a molar mass of 1.01 grams per mole, that equals 4.04 grams per mole due to hydrogen altogether. And finally, we need the molar mass of oxygen. Oxygen has a molar mass of 16.00 grams per mole. And we have 3 oxygens. So 3 times 16 is 48.00 grams per mole. The next step is to calculate the molar weight of the compound, so we're just going to add these together, and we get 80.06 grams per mole. Finally, we take the mass of each element, the mass of nitrogen, the mass of hydrogen, and the mass of oxygen, and we divide by the molecular mass and multiply by 100 to get the percent by mass of each element. So the percent by mass of nitrogen is equal to the molar mass of the 2 nitrogens, 28.02 grams per mole, divided by the molar mass of the entire compound, 80.06 grams per mole, times 100, and that's 35% nitrogen. Hydrogen, we have 4 hydrogens, so that's about 4 grams per mole, divided by 80.06 times 100, and that's 5.05% hydrogen. Even though we have 4 hydrogens compared to the 2 nitrogens, hydrogen only makes up about 5% by mass of the compound because it's just so much lighter. And finally, oxygen, we have 3 oxygen molecules, 48 grams per mole, divided by 80 grams per mole, and it's approximately 59.96% oxygen. So ammonium nitrate consists of 35% nitrogen, 5.05% hydrogen, and 59.96% oxygen. These should add up to 100. I think we're off. We have slightly larger than 100%, and that's just due to rounding. I hope you enjoyed the video. To get more stoichiometry help and a free gift, go to purplestoic.com. This is Melanie Fine of Chem in 10.